This is CS50 week 2. We're excited to have like a little group here, so feel free to drop questions in the chat. Hopefully this will be an interactive session, so I'm going to be asking you guys for some input, and you can feel free to ask questions as well. So let's get started. So I'm Kelly, if you haven't seen me before. I'm the preceptor here at Harvard, so I run the college class on campus here. That's my email if you ever want to contact me. And so this week, week 2, we got more in depth on C. And so some of the questions that in lecture David addressed, and some questions that you might still be thinking about, are what steps are involved in compilation. So how does code turn from source code to what actually runs? When should we use arrays? What are strings? And what's the point of command line arguments? What are these things? What's the difference between a standard input? And then finally, a question that you might be thinking about as you write your code is, what makes for good design? What does design mean? And as you may know, design is one of the axes that we grade for. And so what are we looking for when we think about good design? So we're going to start with that point, and I'm going to ask you all what you think are some characteristics of good design in code. So feel free to write in the chat, what do you think good design means? Simple, easy for someone else to read, not verbose. Yeah, so is it helpful for someone else? Can they understand what's going on in your code? Is it efficient? Is it simple? Yeah, these are great. So some of the things that we came up with that you can think about when you're writing your code. First question is your code efficient? Yeah, no, don't repeat yourself. So as this slide says, we want to avoid unnecessary repetition and redundant operations. So you should avoid copy and pasting your code, even if you're making slight changes. And that usually should be a sign. If you're doing some copy and pasting, perhaps this is a good time for you to consider using loops or abstractions, using a function to try to hide away some of that repetition. And then with redundant operations, if a variable is computed multiple times, that can be also a sign that maybe you should consider storing this variable and storing this value in a variable so that you're not repeatedly computing the same thing over and over again. Another question you can ask is your code easy to maintain? So if your problem gets bigger and bigger, is your code going to be easy to keep up with the scale of what you're working on? So two things to think about here are prototyping your functions. So as a reminder, this is when you're declaring potentially a helper function, so a function that's helping you solve the problem you're doing, and taking that first prototype, the first line that declares this function, and declaring it above your main function. And so it's easy for other humans to read, and it keeps your main code at the top. And so that's helpful. Another thing we like to note is to avoid magic numbers. So what does that mean? Magic numbers we think of as hard-coded numbers. So these numbers that might seem a little bit arbitrary, and their value will not change throughout the program. And so if that's the case, we encourage you to use constants, so define that as a constant. For example, something you might do in this week's problem set is use the fact that the alphabet has 26 letters. And so over the course of your program, the alphabet is not suddenly going to add more letters. And so that is a number, 26, that might be good to define as a constant rather than just simply typing in 26. So to sort of reinforce some of these ideas, we're going to play a little game. I'm going to show two pieces of code, And I'd like you to put in the chat, which one do you think is better and why do you think that? So take a second to think about that, read the pieces of code here. Yeah, so I'm seeing people are saying the second option, option B, is better. Someone says A. Yeah, so the difference here we can see is that in option A, in this conditional check, we're checking is I less than the length of some string. Option B, we're declaring this length of the string, sterling, as n, and then the conditional check is I is less than n. And so we would prefer option B in this scenario because we don't have to perform this string length computation every time we run this loop. If we kept it as option A, we'd be doing a lot of unnecessary computation because we have to get the length. We're asking every single time, how long is the string? How long is the string? When you run this loop, it's not necessarily going to change lengths. All right, so how about this example here? So we have option A and option B. All right, yeah, so I'm seeing a lot of people say option A. So as we see here, talking about magic numbers, option A declares months in a year equals 12 as a constant integer. And so, like someone said in the chat here, the number of months in a year are not going to change throughout the course of your program. And so having that defined as a constant is arguably better design than having just a 12 in your code where someone reading it might not know what that means. So this is a good example of avoiding magic numbers. Okay, how about this example? So we have two if statements here. Okay, yeah, so I'm seeing some people say A. Does anyone want to make a guess as to why A might be a better option here? One less line of code. It's redundant to ask else. Yeah, so that's exactly right. So in these two options, we see option A, we're checking if some expression is true. If that's true, let's return a success. Otherwise, we'll do return a status code of 1. And the other option, option B, we're still checking that expression, but in the case that the expression is not true, we're also adding an else case here. But the else case, as people are saying, is redundant because you're not going to reach that in any other case. And so no matter what, we're going to be returning 1, and so it's not necessary to have that extra case. Okay, how about this next one? So this is also a conditional. Which flows better? Which one's better designed? Okay, yeah, so I'm seeing a lot of people say B. And why might that be? It's more succinct. If false, exit immediately. Yeah, so what's going on in this program is that we have some Boolean that's storing either true or false, and we want to check if that is true. If success is true, we're gonna do a lot of code. We're going to run a lot of things. If it's not true, then we might have some exit case, like you should just stop the program immediately. And so adding that as a guardrail at the beginning, before you have your lots of code, is arguably like easier to tell what's going on here, and because it is a little bit more succinct here, we're avoiding that extra else case. Okay, great. So just want to pause here if anyone has any questions about design, what we're looking for in design, any of those scenarios. Okay. All right, so let's get into the actual, question. So we only need to use else when we have more than 2 possible answers or options. Yeah, so it'll depend on the code that you're running, but you can think about whether or not adding this else case is going to be redundant or not. So is the code within your else block going to run in either case, like if you had the else block or if you didn't? So that's sort of a good way to tell. But thank you for the question. Okay. Anyone else? Okay. Feel free to drop more questions in the chat and we'll move on to the content of this week. First of which, we're talking about arrays. So as an example, some of you may know this game Pac-Man or have seen a leaderboard like this on a video game. And so if we were making a video game of our own here and we wanted to store the top 5 scores of our players, so far the only way we know how to do this is by declaring like 5 integers, maybe score 1, score 2, score 3, score 4, score 5. But that is not necessarily going to be the best way to do this, right? It's a lot of variables to keep track of, and it's not super well designed. It's a little sloppy, right? And so arrays that we introduced this week are a nice way of categorizing or storing these items together. So you might imagine that we have an array like this that stores our top 5 scores in Pac-Man. So if I were to try to actually declare this array, how do I make this array? You might write a line of code that looks sort of like this. So we have int scores, square brackets, 5. And so what is this actually composed of? First we have the name. So we have a name of the array, in this case called scores. We also specify the number of items we're going to have in this array, which in this case is 5. And then we also have to specify the type. So what are the items going to be? What type will they be? So in this case, integers. Okay, and so that's how I declare like an empty array. We don't have any values in it. How might I update this with, say, our first score, our highest score? So that might look something like this, right? So arrays are 0 indexed, meaning that the first thing in the array we call like index 0, and then index 1, 2, 3, 4, and so on. So if I wanted to set the first highest score to 120, I would write a line of code like so that says the name of the array, so scores, at the index of 0, we're going to set that equal to 120. And so similarly, if I wanted to update the next highest score, it would be scores at the index of 1 equals 86. So on and so forth, we can fill up our entire array. If you knew all 5 ahead of time, this is another way of doing so. So you can immediately declare the array scores with its 5 values in curly braces like so. And that would set up your array like this. Okay. If I have this array and I wanted to say print them to the screen, so we're like showing the leaderboard, we might have a for loop like so. So I've set up my array of scores like so, and then I've set up a for loop that starts at 0 and goes up to 5, which means it's going to repeat 5 times, which is the amount of scores we have. And then for each repetition, we're going to print the placeholder of an integer and have scores at the index of I. So what's going on there? Well, you can think of the first time this for loop repeating, I is going to equal 0. And so on that first iteration, we're going to print out scores at index 0, which is like the first score of 120. And then on every subsequent iteration, I is going to go from 0 to 1, 1 to 2, and then print the next item in the array. So that is one way that we can print out the items that are in our array. Okay, any questions about arrays, working with them, declaring them, updating values? All right, feel free to drop them in the chat if you do. We'll move on to strings. Okay, what if you don't know the size of the array and want it to be updated by user input? That's a great question. And this actually will be something that we address in a coming week. But one way to do so could be actually that you just ask the user first, you get the size, and then you declare the array. So that you actually know that length. Arrays are always dynamic. So if you have experience with Python, it is a little bit different. Python's like lists versus C's arrays. When you declare an array in C, that's the length that it's going to be. Like that's the memory that's allocated. You can't necessarily change that, but in coming weeks, we're going to learn about another data structure that is dynamic. You can add more things to the end of it and change that length. So great questions. What's the difference between an array and a list? Does C use lists? C does not use lists. And you can actually, we'll talk about this in Python week when we see those differences. But C uses arrays. Those are, static. They're not going to be changing lengths. Python does use lists, which are a little bit different because they're a little bit more dynamic. But you'll hear more about that in Python. Okay, so we'll move on to strings, which, do they support multiple data types? No, so that's actually a good question. In an array, every single item in that array, the element has to be of the same data type, which is why when we declare an array, state that very explicitly, like int scores, square bracket 5, right? That's gonna be 5 integers in an array. Great question. Okay, so we'll move on to strings. Strings, as we heard in lecture, are actually not a keyword that are in C natively, right? So this like string variable type is actually a CS50 provided training wheel per se, before we actually dive into what that is. But one thing we did learn is that just like an array, a string can actually just be thought of as an array of characters. So in this case, if I have the name Emma, the way you can think about it as an array, name is actually going to just be these 5 characters, right? So EMMA, and then what is that \0? Does anyone want to put that in the chat? What's that for? Null, yeah, exactly. So that \0 indicates the end of your string. So when it's stored in memory, you know exactly where that string is ending. So in the same way that strings are arrays, just like arrays, we can actually index into them to get certain characters. So if I wanted to get specifically the first letter of this string, I can do this same square bracket notation to index and get the 0th index. So in this case, name square bracket 0 would get us E. Why do we put the end on the string? So the null character is helpful because just so that when it's in memory, or if you're working with strings, if you encounter the null character, then you know that the string has finished, that the string that's the end of the string. Great question. Okay, and so similarly, if I wanted to get the second character, I would do name at index 1 and so on. Any questions about, more questions about strings and how that works? Okay. All right, so we're gonna put this into practice a little bit. It is NUL, yes, NUL, I believe. Yeah, great question. Okay, so we're gonna start out with this exercise. If you're watching this asynchronously, I encourage you to pause here and give this a try for yourself. But we're gonna walk through this. So this exercise, character by character, we wanna write a program called print.c that takes a string as input from the user and then prints it character by character. Okay, so we're gonna move to the terminal. Okay, oops. Okay, I'll restart my code space here. What are the operations that can be performed using strings? That's a great question. So, as we'll talk about very shortly, strings and each character within them, the character is also represented as, can be represented as a number, right? So capital A on the ASCII table is equivalent to capital A, or 65, yeah. And so you can do these sorts of operations where you add, say, 1 to 65 and represent that as a character, and that will be B. And so we're gonna actually do this in a following exercise, but let's start out here. We're gonna hide this away. And we're gonna start by coding print, oops. Okay, we're gonna start by coding print.c. And we're gonna include some libraries to start with. So what are some libraries that I know I'm gonna use? I know that I'm gonna be using getString, which is in CS50.h, so I'm gonna include that. I also know that I need standard IO, yep. Standard IO.h. And I also know, actually, yeah, we'll start with those two. And then I'm gonna do main void here. And so first off, I wanna start by asking the user for some input. So I'm gonna do string text equals getString, and then ask for some input here. All right, and so once I get this text variable, how am I gonna print it out, character by character? So if I'm doing it character by character, what might I use to do something repeatedly? A loop, yes, thank you. Okay, but what kind of loop? That's the question. So we could do a for loop, we could do a while loop. Okay, so people are saying for loop. Yeah, let's do a for loop. So for int I equals 0. And then what is this for loop? How many times is it going to repeat? Depends on the user's input, right? So how do I get the length of the string that the user is going to input? Stir length, yes. Yes, okay, great. So I can use strling, which is a function that is actually in string.h. So I also need to make sure that I include that up here before using it. So this is going to go up to the length of the text, and then each time increment. Great. And then for each iteration, I want to print out, what am I printing out here? If I want to do character by character, yeah, %C, which is the format code for a character. Great. And that will be a placeholder for my character within the text, right? So which index am I going to do here? Yeah, people are saying text at index I. Yeah, so that I is going to iterate each time. Someone asked about including the \n. What might that do stylistically? You think about. I can also show you. Yeah, okay, that's going to put each character on a new line exactly. Yeah, if I included this \n, rather than seeing, like, if I put Kelly, my name, we would have K on one line, then E on the next line, L, and so on. So let's start by making this print, /print. Wait, put in my name. Yeah, so if I include the \n, then it prints it out on each line. Right, as someone's saying in the chat, if I want a new line at the end of printing it out, I should include a \n here instead. So let's make print again, /print. Great. So we've printed out what the user has given us. Any questions about this exercise? Feel free to put them in the chat. And we're actually going to take this and extend it a little bit, do something fun with it. So we want to write a program reverse.c that takes a string as input and then actually reverses it. So the last character becomes the first character, and so on. So I think I will create a new program called reverse.c. And since we started out with this, let's just use this as a base. So we're already asking for our input, but now instead of printing it in order, we want to be printing it in reverse order. So how might I do that? Perhaps what line of code, which part of this for loop am I going to need to change? Yes. So people are saying like I minus minus. Sorry. So I'm going to be decreasing I each time and perhaps starting I at the length of the string. We can do decrement. Yeah, great. And then if I start I at the length of the string, then what condition is going to be true for us to keep incrementing or decrementing each time? So as long as I is greater than 0, great. We're going to keep repeating this. Okay, awesome. Okay, so let's give this a shot. Do make reverse, /reverse. Oh my gosh, reverse. This is CS50. Okay, interesting. So this is almost right. What's off about this? There's like one slight mistake here. The T is missing, yeah. So it printed everything out except for this last character, the T. And so that means that our for loop is not repeating enough times. It should be repeating one more time. Yeah, so one way we could do that is changing this to be greater or equal than 0. Another way, as some people wrote, is I could just start it one higher than the length of the text. So I'm just going to go with changing that. We can make it again, do /reverse. This is CS50. Okay, great. And this is correct. It's functioning correctly. Does anyone notice anywhere, I guess not true in this one, but in our previous example, what's a design decision I can make to make this a little bit better designed? Assign str length to a variable. Yeah, exactly. So this is one of the things that we saw in our design chat earlier, but declaring this length here prevents us from doing some extra computation when this for loop is running. Okay, great. So we've done these 2 exercises. Drop in the chat if you have any questions about them. But we're going to continue from here. So working with strings a little bit more, if you recall, each of the letters that we work with by the ASCII table that was decided by some humans a long time ago, have declared these numbers to be equivalent to these letters. And so because they have these numerical representations, we can actually do some like operations and checking things using these numbers. And so one example of that might be so Emma, for example, this string here, actually can be written out as this array of integers. And so why is this helpful information to know? Let's try seeing that in this exercise. So we're going to write a program called alphabetical that prints out yes if a lowercase string's characters are in alphabetical order, no if they are not. So right off the bat here, how do I know if something is in alphabetical order? Say if I got A, lowercase a, and lowercase b, how would I know that these 2 things in order are alphabetical? Yeah, so someone says if x is less than y, as we saw with this chart, b has the value of 98, which is greater than a's value of 97. So we can take that piece of knowledge into this exercise and come up with a way to check if our string is in alphabetical order. So I'm going to start coding alphabetical.c. And then, like before, I'm also gonna, let's just build on this, print.c. Okay, so the first part is the same, right? We're asking for an input here. But now we're not gonna be printing out anything within this loop, but we do wanna check whether the characters are in alphabetical order. So like a few people have said here, we're going to be checking the ASCII value. We're going to be comparing it. So let's see. I could do an if statement. And then what might this condition look like here? Let's say if I want to check the first letter against the second letter. Or perhaps how do I get the first letter of this text variable? Yeah, text.I, text 0. Great. So 0 index would get us the first letter. And of course, because we're doing this within a loop, that's great. We're starting with I equal to 0. And so we want to check if that's less than the next letter, which is going to be I plus 1. Okay. So if this is true, then what? If these 2 characters are in alphabetical order, then what should I be doing? Print no. So we want to print no if it's not in alphabetical order. Yeah, so we're not really doing anything if this is true. And so when we have cases like this, it might be good to think like, how can I restructure this? Maybe to change this, or this condition. So rather than checking if it is in alphabetical order, maybe we check if it's not in alphabetical order. Right, so if this is greater than the next letter, then we already know that the rest of the string is not going to be in alphabetical order. So we can print F, no. And then just finish this program, return 0. Yeah, exactly. Okay. So if we loop through this entire string, and we're checking each 2 letters one by one, which if they're in alphabetical order, and we get through the entire string, then we know that, yes, if you've gotten to this line 17, and you haven't returned the program, then we can say, yes, it's in alphabetical order. Okay, so let's test this out and see how it goes. Length. Okay. Okay, so I'm going to do ABC, not in alphabetical order. Why might that be happening? Text I+1 will not exceed the string boundary. Yeah. So just to show this more visually, if I print F, the character, or maybe the integer version of text I, and then at index I+1, we can see like what values are actually being compared here. So let's make this again. ABC, oops. Okay. Yeah, so we see these are the first 2 that we're checking, A and B. That's in alphabetical order. The next 2, A and S by accident, but that's still in alphabetical order. But then it's checking S and then 0, which in this case, if anyone remembers, what's this 0 referring to? The null character. Yeah, exactly. The null character at the end of the string is what it's comparing it to. So we know that we're going a little bit too far in our comparison, that we should actually just stop here. So we can say finish, or continue running this as long as I is less than length -1. So it repeats 1 less time than before. So let's try this again. ABC, yes. And I can remove these print statements now that I'm done debugging. Okay. So our last portion is talking about command line arguments. So what are some examples of programs that we've seen that take command line arguments? Cowsay, yeah, exactly. From lecture, cow program. So that takes some arguments. Also, things that you've been doing this past week, make Mario. Mario in this case is a command line argument. Make is the command. Same with when I run something. This is something you might encounter this week, where you actually provide the program that you're running some input, in this case 13. So this is no different than the functions that we've seen before, right? When we had this calculate quarters function from cache, it takes in a function argument, which is an integer that we call cents, and then it specifies the type that we're returning. So in this case, it returned how many quarters that we had. Similarly, we have int main void that we've been seeing a lot. And so up until now, we've used void as this input argument. It means it's not taking anything in. And then it's returning an integer, which, like in lecture we talked about yesterday, that is the exit status. That signals like if it ran successfully, like a 0, or if it ran into some error. So now, rather than taking in no input, we can try experimenting with including some command line input. And so that's what this looks like. we have int argc, which is like the count of the arguments, how many arguments were put in, and then a array of strings that has the actual commands that were put in the terminal. Okay, so a question that might come up for you is like, why are we even doing this? Why not just use getInt or getString? So, any thoughts on this in the chat? Why might you prefer to do something with command line arguments? Yeah, it saves time. Yeah, so you could think about if I were running make Mario, instead of running with a command line argument, say you had to type in, like, it asks you, what program are you trying to make when you run make? So it saves some time. Yeah. Yeah. Great. So this is what those arguments are actually going to look like here. If I run make Mario in terminal above, then we're going to have a string array called argv that contains the string make and then the string Mario, and then an argument counter variable which has the count of that array, which in this case is 2. Same thing if we had something like /Caesar and then 13. So that has /Caesar as the first string and then 13 as the second string. Okay. So now let's say we're going to make a program called initials that takes some person's name, in this case my name, and then spits out the first character of each, giving us like the initials, in my case KD. Well, with argv, we know that argv0 is going to be this /initials string, and then argv1 gives us my first name, Kelly, and then argv2 gives us Ding. And then because these are strings, we also know that if I wanted to get the actual letters within that string, I can do argv at index 1, which is Kelly, and then at index 0, it's the first letter, which is K, and then similarly with D. Okay, so any questions about command line arguments? What would argc be? Great question. Anyone else in the chat want to answer that? What would argc be in this scenario? 3, yeah. Yeah, so /initials is 1, Kelly is 2, Ding is 3. So we have 3 arguments. Okay, so let's move on to this final exercise. Why does it count from 1? Yeah, great question. So argc is giving you a count of how many arguments there are, rather than when we talk about counting from 0, it's usually like an index in an array. And so rather than saying, so the array still has 3 elements inside of it, which is why argc is 3 in this case. But when we're actually doing the indexing, the first is called 0 index. Great. Okay, so let's do this final exercise. Write a program initials.c, just like we saw, that takes the name as an input and then outputs their initials. So we're going to accept them as command line arguments and assume that names will be separated by space. Okay, so let's move over here, clear my terminal, and code initials.c. Okay, so I know I'm going to need some libraries here. CS50.h for string, since we know we don't have string, and standard.io.h. Okay, we might need some more, but we can always come back. So I'm going to start with int main, and then instead of void here, I know I'm going to be taking in some command line arguments. So I'm going to have int argc and then string argv. Okay, so I know that I'm going to be needing the string in each command that was inputted. So I should probably do a loop, right? Okay. What should my loop start at? Say, if I'm given /initials, Kelly Dang, right? So let's say this is my input. If I want to loop over just these two strings, what should it start at? My for loop. argv1. Yeah, so this is argv1, this is argv2. So let's start this actually at 1, and then loop as long as I is less than, what should it be looping until? 3. Yeah, so it could be 3. I also specified, and maybe I actually put my middle name in here. Now this is 4. So what variable captures like this, the number of arguments we're gonna have? Okay. I'll give it to you for free here, argc. So argc, as a reminder, is the number of arguments. It's like count. So in this case, it would be 4. In this case, it would be 3. And so it changes dynamically, which is what we want here, rather than me just saying it has to be 3. Some people have multiple middle names, maybe, so you want to capture different scenarios. Okay. So now that we have this looping over each part of the name, how do we print out the first letter of that name? So what should I print out here? Is it possible int n equals argc? Yeah, so you could do that. But if you don't necessarily need to save argc as its own variable, as it's already a variable. Okay, yeah, people are saying argvi at index 0. Great. So I'm going to print out a character, and that character is going to be argv at index I and position 0. Great. So let's try this out here. /initials KD. Great. I want to start it on a new line just for stylistic purposes. Let's just add a new line there. Oops. Okay, and then great. Okay, what if now I did initials and then just didn't give it any input? It just prints out nothing, but I might want to actually handle that, right, and tell the user, you're supposed to give me some input. So how might I check that here? Use an if, yeah. So I should check, like, did this person input any arguments? How might I do that? Say I want them to have inputted at least 2. Yeah, so if argc is less than 2, meaning they either didn't put any arguments after /initials, or they have nothing, which is not really the case here, but right, so if this is not less than, or if it is less than 2, then we should just say the correct usage of this program is initials, and then like your first and last name. And then we should just return 1, signify there is an error. So let's make again and run. Okay, great. So now rather than printing out nothing, it actually gives us this error message here. Okay, let me make one last time. And try this with David's name. DJM. Great. Okay, awesome. So any questions on this program? So people are saying if argc does not equal 3, yeah, we could do that too. That would just mean changing, let's say, for this case, then it wouldn't work since we have 4 arguments. Yeah, so these are all design decisions that you as a programmer are going to be thinking about when you're writing your program. Okay. Awesome. Okay, so that's all of the content for this week. Thanks for your participation.